This is the topic 3 video for chapter 5, solving multi-step inequalities. So essentially when we do this, we solve it just like a regular equation. We take the same exact steps. The only thing we need to worry about is flipping the sign if we multiply or divide by a negative number. So for our first problem, if we had 3x plus 12 equals 18, our first step would definitely be to isolate the x term and subtract 12 from both sides. We end up with 3x is less than 6, and then to get x by itself, divide both sides by 3 to get x is less than 2. So when we graph, we need an open circle at 2 and an arrow going to the left. Our second example, we have 3 times the difference of x minus 4, so to get rid of that 3, we can either distribute it to x and negative 4, or we can divide both sides by 3, which is what I like to do. When we do that, the 3's cancel out on the left, and we get x minus 4 is less than negative 5. Add 4 to both sides, and our final solution, x is less than negative 1. So we need an open circle at negative 1 and an arrow going to the left. For the third problem, we do have some parentheses, and we have to use the distributive property, so we need to distribute that 2 first before we can start to solve it. So we'll distribute that 2 and we get 10x minus 8 minus 6x is greater than or equal to 12, but before we can start to solve, we do have to combine the like terms on that left side. 10x minus 6x gives us 4x. Add 8 to both sides to isolate the x term, and then divide both sides by 4 to get x by itself. So we get x is greater than or equal to 5. So we need a closed circle this time, and the arrow is going to go to the right. Our last problem, we have variables on both sides of the equation, so let's get our letters to the left. So we'll subtract 3x from both sides. That gives us 2x plus 6 on the left and a 10 on the right, and then our regular numbers to the right, so subtract 6 from both sides. We get 2x is less than 4 and get x by itself but by dividing both sides by 2. This is the same graph as our first example, open circle at 2, and it's less than, so arrows go into the left. Our first example on the next slide, we've got to isolate the term with the t first. So that means we need to add 5 to both sides as our first step before we worry about the fraction. So we have a negative t over 6 is greater than or equal to negative 4. And now to undo the division by 6 and get rid of the negative at the same time, we're going to multiply both sides by negative 6. So we get t on the left, positive 24 on the right, and this is where we can't forget to flip our sign. We multiplied by a negative, so we change it to a less than or equal to. So we need a closed circle at 24 and an arrow going to the left. Our second example, we do have a fraction, but we only have one term. It's one whole term. So let's get rid of the fraction first by multiplying both sides by 2 to get that cancel out on the left side. Then the only thing left to do is subtract 3 from both sides to get w by itself. So again, be careful when we plot our scale for the number line with negatives. Negative 20 is on the left of negative 19. And we need an open circle at negative 19, an arrow going to the left. Our last two are special case scenarios, so I'm going to go through this a little quickly to get to the final part. So we're going to use the distributive property on both sides, combine like terms on that right side. And then when we move our letters to the left, when we subtract 12m from both sides, they cancel out on both sides. So we're left with 18 is less than or equal to 18. That's a true statement. We call that all real numbers. And the graphical representation is that arrow that goes both ways. So any number is a solution. The opposite scenario is on the right. When we use the distributive property on both sides, combine like terms on that left side, when we get our letters to the left, they cancel out again, but this time we're left with a false statement. 25 is not less than or equal to negative 12, so that's no solution, and there's no graph for no solution. We just leave it blank. Go ahead and do the U-tries on this page. For the verbal sentence, it's the same as what we've been seeing on the last two. So 4 more than the quotient of a number in 3 is x over 3 plus 4. At least, it can be 9, but it has to be at least 9, so 9 or more. So we need greater than or equal to 9. Start by subtracting 4 from both sides to solve, and then multiplying both sides by 3. You don't have to graph these. I know it says on your paper to graph, but you don't have to. Our next one, negative 3 times a number increased by 7. Negative 3 times that number x increased means add is less than. So that one's easy, just a less than sign, negative 11. And then solve. So subtract 7 from both sides, then divide both sides by negative 3. But be careful, we divided by a negative, we've got to flip our sign. Last one, 4 times the sum of a number and 2 increased by 3. So we got a lot going on. Anytime you have 4 times the sum of something, you've got to put parentheses around the sum. So 4 times the sum of x plus 2 increased by 3, so add 3 after that parenthesis, is at least, so same as the first one, greater than or equal to 27. And then solve. Use the distributive property. Combine like terms on the left, and then do your solving process. We get x is greater than or equal to 4. Go ahead and do the U-tries on this last page, and that's it.